Dr. Todd Citron, sitting in the middle. So Todd leads Boeing's global technology strategy, overseeing a 3,300-person organization that includes Boeing Technology Innovation and Aurora Flight Sciences across 5 U.S. and 8 international research centers. He co-leads the Horizon X Venture Partnership and has overseen advanced air mobility efforts such as WISC and SkyGrid. Previously, he served as VP of Engineering for Boeing Defense, Space, and Security and held senior roles in development and mission assurance, leading large global engineering teams and driving technical integrity, risk reduction, and program execution. He led development of award-winning small satellite systems that grew into a multi-million-dollar business, holds 3 patents, is a fellow of both the Royal Aeronautical Society and AIAA, and earned a BSc with distinction from Purdue and an MS and PhD from Stanford. And last but not least, I'd like to introduce Don Ruhmann. Don is Boeing's Chief Aerospace Safety Officer and Senior Vice President of Global Aerospace Safety and serves on the company's Executive Council. He leads Boeing's global aerospace safety strategy and is accountable to the Aerospace Safety Committee of the board. Previously, he oversaw development programs for Boeing commercial airplanes and has held senior engineering and program leadership roles across the 787, 777, and 777X programs, with additional experience in post-delivery commercial aviation services. Don joined Boeing in 1989, holds a master's in applications of physics from the University of Washington, a bachelor's in aerospace engineering from Texas A&M, and is also a licensed pilot. So I'd like to welcome both of you to the stage.
Thank you.
All right, so we're just going to jump straight into some thought-provoking questions. So first, let's start really big. The story of aerospace has always been shaped by bold leaps, setbacks, and hard-earned lessons in between. Don, Todd, from where you sit today, what do you believe the next defining chapter of aerospace will be? And how is Boeing preparing to help write that chapter for commercial aviation, defense, and space?
I'll start. Yeah, I guess I would suggest that one of those chapters needs to be making our airspace system that's already safe even safer. If you take a look at commercial airplanes over the past 2 decades, the accident rate has come down 40%, fatal accidents even greater than that, all while numbers of departures have gone up above 20%. So to get there, to be able to repeat that in the next decade, we're going to have to think about things differently. We're going to need new tools, and we're certainly going to need new data streams. I gave you, in commercial airplane example, but the safety analysis tools that we use across our aerospace products, whether it's defense, space, or commercial, are essentially very, very similar. Whether it's rooted in the ARP or the mil-spec, the work we do is very similar. It's just that the missions are very, very different between a fighter and a commercial airplane. But the work is quite the same. In the end, safety is life, and that's what the whole objective is all about. It doesn't matter which product we're talking about. If one of the things I really like about our space launch system team reviews is that somewhere in the deck you're always going to see a picture of the 4 astronauts, and the mission is all about getting those astronauts home. So you ask about new ways of thinking. Traditionally, we've always thought about how to stop the bad thing from happening. We've always looked at failure modes and Paretoed them all out and done root cause corrective action. And we're never going to stop doing that. As an industry, we're really, really good at that. But what we're talking about is layering on top of all of that a safety resilience body of work that focuses on the positive outcomes or the intended outcomes of what you want to happen, not just preventing the bad things from happening. So to do that, we're going to need certainly new data streams to do that. And it's going to we're going to have new ways of collecting data, and in the end, to try and influence those positive outcomes from happening.
Yeah, just building on what Don said, on the technical front, similarly, there's chapters that are continuing and new chapters to be written. On the continuing, let's talk about efficiency. And by that, I don't just mean fuel burn, but the efficiency of aerospace. So if you look from the beginning of the jet age to now, the fuel efficiency of aircraft improved over 80%, which is a pretty phenomenal achievement, but we have a lot more that we need to go. There's another 80% that's really important, which is about 80% of the people on this earth have not flown on an airplane. And when we look at how COVID retaught us the human need to connect, aviation plays an essential role in that. So it's incumbent upon us to continue to drive the efficiency of the airspace system. So that includes, of course, making our airplanes more fuel efficient. So that's new propulsion technologies, new aerodynamics, but it's also how we operate the aircraft in the system. And with more integrated system level optimization, we can not only improve the fuel burn by 10% or more, we can also substantially more than that increase the capacity of the airspace system, and that's to the benefit of the population of the world. It goes back to the people aspect that Don's talked about. In terms of new or newer chapters, I'd highlight autonomy and advanced automation. Clearly, the technologies, both in terms of the hardware and the algorithms, have advanced considerably. And the ability for the machine to do as well or better than the human in ensuring safety that Don talks about is really a critical opportunity. There's a lot of emphasis on the defense side, of course, with fully autonomous systems, and we play significant roles there. But just on the commercial side, that advanced automation to make things more repeatable, to build in all of the learnings over the years about how to operate safely, we can build that into the systems that we design. And something that connects the two of these is the use of artificial intelligence. It permeates everything that we are doing now. It's really significant. And as I think we'll talk more later, it's not only the technology, but how the use of artificial intelligence in the design process changes the role of people. And I think that's a really important challenge for us to take on. Back to Ray.
All right, thank you. Well, thank you, Todd, because that just takes us straight into our next question, which is really focusing on advancing innovation. And you both represent forces that must work hand in hand in our industry to keep advancing breakthrough technology and uncompromising safety. Don, you've said safety is at the core of everything we do. Continuous learning is required to achieve the highest levels of safety, and now adding on to that with people in mind. Todd, you shared how machine learning and autonomy are already spotting degradation earlier and tightening manufacturing tolerances. With that in mind, how do your organizations collaborate so that when we push into the areas such as digital engineering, autonomy, AI, we're not just moving fast, but moving safely and smartly?
No, it's a great question, and that connection is critically important because something is not useful unless it's safe for humans. And so I think the starting point is to say there's not really a conflict there between innovation and safety. A lot of times people say innovation loves constraints. That people become more creative with those constraints. And instead of thinking of safety as something you do after you've designed the product, we've a long time ago moved towards you have to bring the safety equation up front into the very beginning of the design process to build it in and not add it on. And just a couple examples. So in the factory, we have cooperative robots or cobots, and those do a number of good things. They take away ergonomically unhealthy operations within the factory. But to make that all work, we have to have those robots be able to work collaboratively and safely with humans. And we can only do that if we build that capability in up front. And so our cobots that we have deployed in our factory, so they not only can do amazing operations with various types of end effectors, they also do it safely because from the beginning we built in the safety sensors to understand if there's humans nearby and into the operating system, making sure that humans were kept safe. Another example of this is runway incursions are a significant source of safety instances. And the ability for a machine to be sitting in the cockpit advising the pilot on whether there's a perception of a vehicle incurring on the runway and being able to advise the pilot to then go around is important. We've actually demonstrated that technology, and that's in our future roadmap. So this idea of innovation and safety, it's not one or the other. It's really, they go together, and they actually can help each other to give us better products.
Yeah, I'll just pick up on the AI part of the topic because I think that fits in really well. You already had a couple really good examples. When you think about AI in safety analysis, I'm an AI rookie, and I don't understand the algorithms yet, I say, so I don't actually have the trust in all of that work. But when you listen to what Todd talks about and you think about the future of the integration, even in a flight deck of AI, the possibilities seem endless. And so we really need to get on board with this and further it along in our industry and a number of different practices. However, it has to be wrapped in engineering ethics and an understanding of human factors influences that we all have to think about as we go along. Where you insert AI into the decision-making process can really influence potentially the outcome. Collaboratively, we have an AI leader at Boeing and an AI team, and this is where the governance around the development of the algorithms and the usage on certain data sets happens, because they're the experts and they understand that. In the enterprise safety area, we also have a safety analytics team that uses those algorithms, and that's really where the governance around how to use the algorithm, where it's appropriate to do, wanting to make sure that we're not replacing the decision making, but we're supplementing the decision making, and that we have an engineer in the loop with the wisdom to understand the output in the end.
Thank you. I have a follow-on question for you, Todd. So you mentioned cobots. I'm assuming the majority of people know what cobots are, but could you explain that a little bit more in depth compared to what a robot is? And when did we implement those, and what are some of the efficiencies that we've gained with the implementation of cobots?
Yeah, great question. So cobots are cooperative robots. These could be 2 or more robots that are just that, cooperating with each other to accomplish an operation, or they could be robots that are cooperating with humans. So just an example, and I'll say this is work we've done down at our Boeing Technology Innovation Australia team has developed the operating system that goes with this. And so it's a mobile platform that has the ability to auto-register where it is, so it can find, if it needs to do an operation on a particular part, it can find where it is and localize itself. And just as an example, we have molds, for example, that need to be cleaned and sanded, and that's a very arduous operation for a human and leads to all sorts of potential health issues. And so we've developed a cobot technology that allows the robots to autonomously sand the mold to clean it. But at the same time, we have people that are interacting with these molds, and we want to make sure that we don't have to fence off the whole area while the robots are doing their work, but instead make it safe, as I talked about earlier, for the humans to be right there with them doing their operations while the robot does the more arduous types of tasks.
Yeah, thank you. I know when I started in the early 2000s, robots were not, or cobots, weren't really in our factories, and now you walk through and there's so much automation. It is just impressive. I'm excited to see what happens next, especially as we join AI knowledge with our cobot knowledge. Okay, let's move on to the center of our questioning, and I call it the center because we are talking about breaking through the toughest barriers, our 2026 SciTech theme. Todd, you've said challenges are really opportunities, and it's exciting to be in a period where there are so many opportunities. With so many technical, cultural, regulatory, or organizational challenges in aerospace, how is academia, government, and industry baking barriers together? And do you have some examples of where we've been successful or where we can push more.
It's a great question, and I think it's fundamental. I think it's important to realize there are a lot of smart people around the world and in different sectors of the economy. And if we're not taking advantage of all that intelligence, then we're losing out as a culture, as a people. And so just one example of that, I talked about improving efficiency and sustainability. So no one company, no one sector of the economy really can solve that problem, because if you just think about, for example, sustainable aviation fuel as one of the keys to reduced carbon emissions, that takes folks like ourselves, OEMs, it takes regulators, it takes oil and gas, it takes all sorts of different sectors of the economy. And so until we get everybody together, we can't solve that. So just recently, we held the first Cascade Sustainable Aviation Technology Symposium, or CSATS. We held that on the MIT campus. We had 100 people from 4 different continents, from airlines, from OEMs, from regulators, from oil and gas, just a number of different sectors. And this wasn't just a conference where people presented papers and you listened. These were working sessions that were around 4 topics, trying to get at what were the most significant challenges, and importantly, what are the most promising pathways to solutions. And we didn't do that to keep it to ourselves, so we actually took those results and have published a set of proceedings that are on the cascade.boeing.com website, where you can go to and see these. And we're actually making this an annual event so that we can follow up and drive progress. And I won't go through the details here, but there were just a number of good breakthroughs of understanding some barriers, to your point, and some insights as how we might be able to break down those barriers.
And we just had a collaboration launch at the Future of Flight last week, right, with the Washington State University, the local government, Payne Field, and so we have a research facility that's going in to advance our understanding of SAF. So that's one area where I'm seeing things actually come together. And for those of you who are not aware, we do talk about SAF a lot, the industry does. Only 1% of all fuel used today on commercial airplanes is from SAF. So we have a long ways to go in order to gain the emissions efficiencies from SAF. Don, do you have anything you'd like to add?
No, that's good.
All right.
I have another example, if you like, of this. Go back to the efficiency, but now not emissions, from a fuel perspective, but from an operations perspective. So today, if you travel transoceanic, you're likely to go through multiple air traffic planning regions. And they're all scheduled independently. They're not optimized end-to-end. And there's certainly no capability to bring in real-time traffic, real-time weather information. And so if you've ever circled an airport waiting to land, that's one manifestation of the way the system is designed today. So another hard problem, but working together with regulators and a number of different countries. A couple years ago, we did a multi-regional trajectory-based operations demonstration using one of Ray's aircraft.
That's right.
But the idea of this is to be able to do this end-to-end optimization with real-time data. And so both in the US, in Japan, in Thailand, and Singapore, we actually demonstrated the key technologies that will enable this end-to-end optimization of operations. And I mentioned before, but just to connect the dots, that is estimated to be about a 10% fuel efficiency benefit and reduced emissions. But just as importantly, it's going to increase airport capacity. And in certain airports, that's a really big deal.
Yeah.
So just another example of how the global community working together can really make things happen.
Yeah, absolutely. That was part of the Eco Demonstrator program back in 2023, I believe. And yeah, it was amazing to see academia, industry, and all of the ANSPs work together jointly. Reagan, I'm sorry, this is closed for the questions.
It's one way to filter them.
Yeah, you guys are breaking the internet with questions. All right, let's move on, diving in more into autonomy, digital systems, and also public trust. So as we move toward more autonomous, digital, and fully connected aircraft and spacecraft, The pace of capability is accelerating. We're going to hear a lot of that throughout this week. Don, you've noted that the history of aerospace has shown the importance of long-term investments in the systems and technologies that make our industry the safest form of transportation. To both of you, how can the industry strike the right balance between rapid innovation and the rigorous certification, validation, and public trust expectations that these systems demand, especially as autonomy becomes a reality?
Yeah, I'll start. I think first you have to start with technology is always needed earned trust, right? Doesn't matter what it is, especially with the public. If I think of just a couple basic examples, my wife refused to get a smartphone forever. When we were all using Apple 7s and 8s, she was still using her flip phone because she just didn't trust the technology. She didn't know where it was going to come from. And now you look at today, and obviously she can't get through a day without her smartphone because of the earned trust and the capabilities you have. So you look at that technology and you relate it to public use. The same thing as we're actually coming out here, I ran into another example. I don't know if you've all seen the autonomous wheelchairs in airports now. And I was looking at that and wondering, so who was the first person who jumped in and said, yeah, I'll get on this thing and go down this hall with these thousands of people, not knowing where I'm going to go, with zero supervision. So, they're in the public trust of things. Those are all relatively safe things that we're talking about. But technology always needs to earn its trust, and we have to keep that in mind. Autonomy is really no different. We're going to have to focus on the public's trust of everything that we're going to do. From my perspective, it really starts with your basic systems engineering 101, valid requirements, appropriate verification, and a good communication plan to earn the public's trust. In the end, we all know this, the safest autonomous air taxi is the one that never flies, which is not where we're headed with this. So what we really need to do is focus on working with our regulators, working with the public trust to make this successful.
Just building on that point, I think what's critical is that we do that, and we do that at the beginning of the process. We can't bake it in after the product is designed. And just as an example, I'll use Whisk. So for those not familiar, so Whisk is a Boeing product that is in development right now. It's an air taxi that would carry 4 passengers and their luggage about 100 miles using electric propulsion, battery propulsion, but also doing this fully autonomously. So you talk about trust, it's like, would you get in a Waymo? No, would you get in an air taxi that has nobody as a pilot? And it's all about understanding that in the very beginning. So from the very beginning of Whisk, we've been engaging with the FAA and working our way through the regulatory process, not trying to graft it on later, which would be horribly inefficient and unsuccessful. And so through that process, as well as through many flight demonstrations, flight tests, using those to make sure that we have the rigor from the beginning, that we have the confidence ourselves, and then for our flying public to be able to use this product. So it starts at the beginning. And as part of this, it's not enough just to think about the air taxi, because the air taxi has to operate in a controlled airspace environment. And so we have another entity that's part of Whisk called SkyGrid that for now many years has been working. How do you safely integrate autonomous vehicles into controlled airspace? And so there again, beyond just sketching out what the design would be and starting to develop it, we've been doing a number of demonstrations with drones in controlled airspace and showing what are the real issues and starting to tackle those hand in hand with the regulator, both here in the United States, but also we've done demonstrations down in New Zealand, for example, as part of this. So it's all about recognizing that up front and building it into the design process.
If I could add on just a couple things, themes that have come out already to that discussion with Whisk. The human factors element I talked about earlier. You think about autonomy and the person that's actually control it sitting in a back room, not actually in the flight deck. The human factors elements that we're all talking about are all very different and new, especially in the face of the public. We've done a lot of this with defense work. But when you start talking about communicating with the public and understanding what's going on and giving them the confidence of what's going on in the back room, it's really important. Also, when you think about WISC, to Todd's point about working with the regulator earlier, we're going to have operational certificates, we're going to have production certificates, we're going to have type certificates, and all of this space is new. And so working with the regulator early to actually lay it out and understand how we're going to certify in all those regimes is really important. And then communicating to the public.
Thanks. Don, adding on to that, there's been a few questions from the audience, and the question is, what advancements do you expect in the certification process for the next commercial airplane? I don't think it just needs to be the next commercial airplane. It can also, you talked a little bit about, what to expect with WISC, with an autonomous vehicle. So can you just share some of your thoughts on what that process might be?
Yeah, I don't think there will be major changes quickly. There's a thought process of getting to, instead of a tactical finding of compliance, getting to a systemic finding of compliance, or some thoughts around what that may look like. I think near term, it's more about, at least for the Boeing company, is earning the trust back of the regulator, where we've had some recent events over recent years that we certainly had to take ownership of and work our way through. And so moving to a place of trust in the work that we're doing with the regulator is kind of really the next step. And in the future, there's some architecture changes that are happening. But I think we have to get there first. We have to, the work that we've done in human factors and safety analysis, and the things that we're doing differently is certainly contributing to the certification work we're doing today. And we actually have to mature that and move that to the next phase.
Thank you.
Maybe if I could just add on to that. So separate from process, but if we think about the technical underpinnings of certification, I think an opportunity to help make things more safe as well as to make it more efficient is the continued maturation of the modeling technology. And so being able to mature our models, to validate our models, to be able to better understand what's going on behind and between test points that we fly in flight test, as well as to understand performance under more extreme conditions. I think there's a great opportunity to advance the models to enhance that process.
Thank you. Also following on to this topic, there's been some questions about how are we embedding safety education into the workforce and into our processes. And I think, Don, when you mentioned human factors, that tied perfectly into that question. So would you elaborate on how we are embedding the human-focused engineering design in our commercial aircraft?
Yeah, that's actually a really great question, and we're doing a lot of work on that right now. If you take safety analysis, whether it's common mode analysis, FMEAs, or functional hazard assessments, you can take an academic view of all of that. And if you only take an academic view without the practical application, there's not a lot of wisdom and learning that happens. It really comes down to, as an engineer, you understand all of that work, but the first time you apply it, whether you apply it to flight controls or a waste system or whatever it is, it's the wisdom you gain from start, stop, failure, that hazard made sense, or this one didn't make sense, or it's that part of the work. So we're actually in the middle of trying to partner with the university on taking the academia version of all of that work and layering on top real-world examples that we have from products that we've certified to actually bring it, to your point, to the human level of actually doing the work. So just doing the academic side really isn't sufficient when you get down and in to this type of work.
And just to add to that also, one might think that a technology organization wouldn't have these same safety considerations, but one of the things that we started a while back was even within our technology organization, we run a safety management system. So that from the very earliest days, we're thinking about safety and technology and how those things go hand in hand, what the implications are. So again, we're not waiting to the point that we get to a product development.
Thank you. A couple of more questions from the audience. Todd, this one would be for you. Aerospace is a huge field. Just SciTech has 3,000 papers. From an industry research perspective, how do you choose the most promising fields and topics to invest in?
No, it's a great question. And one thing I find exciting about being at Boeing is that we have a very broad mission. We develop products from undersea to outer space and everything in between. So we have very broad interests in terms of technology. The key thing is, and I like to tell the team this for effect, is I tell them technology has no value unless it transitions into our products, our services, and provides value for our customers. Right. And so unless we connect the dots, unless we're really good, best in the world at not only developing technology, but having it show up in what we provide to our customers, we can't be successful. So the key is to understand in the different markets that we participate in, where do we see those markets heading? What do we think those customers will need? And then taking those needs and translating those into technology requirements so that we connect the dots so that we're not just doing research, we're doing research with a specific end in mind. And so that's really the key to understanding what we focus on.
All right, thank you.
I think it also offers, you mentioned mission. Connect, protect, explore offers endless opportunities. I mean, we are so privileged to have that as our mission, and it allows us to do some really great things for our customers.
Yeah, and I mean, just the collaborations that we have with different partners out there really does help us increase our investments because it has to be value added for the entire industry, not just one entity. I'd like to move on to the future workforce. I'm just curious with our audience, show of hands, how many Boeing colleagues do we have with us today? Okay, a lot. Hi.
It's like we stacked the audience.
Okay, well, nice to see you all. And then how many students do we have in the audience? Okay, all right, this is going to be an excellent question.
Well, we can see who likes to sit at the front of class.
Yeah. Where did you sit? Were you in the front? Where did you sit, Don?
Wherever.
Wherever. I was kind of always like two rows back. Anyway, okay, so let's talk about the next generation of engineers and leaders, many of whom are here with us today. We saw their hands. What technical skills, digital fluency, and mindsets will the next era of engineers need to thrive in an AI-enabled, multidisciplinary environment? What advice do you have for those starting their engineering career? And perhaps what can they expect from the generations ahead of them?
It's a great question, and we have the privilege of working with quite a few universities in sponsored research, and we've been having this exact conversation with many of them. And the thing I'd start with is, no matter how the technology, the capabilities evolve, including artificial intelligence, I think the thing that never goes away is the importance of having that intuitive understanding of how things work. Because the machine can spit out all sorts of things, and sometimes what it spits out is not practical or has other implications. Mm-hmm. But if you don't understand it at the intuitive level, it's really hard to know whether that's true. I think at the same time, though, it is important to recognize that with the emerging technology, especially in machine learning, that the role of the human in the design process is changing. And so, it used to be before the advent of calculators that nobody here probably knows of, you needed a room full of people with mechanical adding machines or things of that type. Or before Excel, you needed a whole room full. Those things went away, and it's not like people went away, the role changed. And so today, I think it's rapidly the case that a machine can much more quickly iterate a design than a human. And we're seeing what that applies to, what those words apply to, grow significantly. But that doesn't mean the human goes away, because the human role becomes then, how do you tell what a good design is versus a bad design? How would you approach a particular problem? And it's not just that, this is almost the hardest part, is taking that thought process and turning it into code so that you can then string that human thought together with the iteration of the machine to optimize the end-to-end process. And this is a very active conversation about how do we take elements of our workflow and automate them. But I'll come back to, if the person involved doesn't understand what good looks like, then it's really difficult to have this be practical. So it's a challenge, and we're seeing it in the press. You know, how do earlier career folks get that experience, that intuitive understanding? And I think at least one answer is, as the digital twins mature, which is happening rapidly, getting to the point of validated digital twins so that if you are an earlier career person, you have that opportunity to interact in an environment and get experience rapidly. So it's a tough problem, but I think it's really important.
Okay.
This is actually really good, and you all are probably not going to believe this, but we actually didn't coordinate this, so we're making it up as we go. But you mentioned interdisciplinary, and you talk about intuition. The interdisciplinary aspect of this is what we do, right? We don't show up and do mechanical engineering and aerospace engineering and electrical engineering. We design vehicles that are all integrated and satellites that are all integrated and require every discipline. And I find that the university students who show up at Boeing today are so much better prepared than I ever was coming out of university, because they're afforded these opportunities throughout their entire years of being at university of working interdisciplinary projects, whether it's a capstone or an SAE formula car or a satellite group that makes us launches satellites. They do that everywhere in university. They make products now. So I think that's a key element of positioning people to be more successful. However, in all of that interdisciplinary work, relative to your intuition comment, you only get about this much wisdom through those years of what you do. It's really when you get out in the industry that you start to see failures and people before you that have failed and have earned that wisdom and that intuition that Todd's talking about. And so my advice is, if you're early career or you're just entering the workforce or you're still in school, that interdisciplinary work is what the industry looks like. And so take advantage of that. If you're already in industry and you've got 30 years, 35 years, then overtly seek out those people and share your wisdom and your failures so that everybody can benefit from all of that. Because to your point, you really don't get a lot of that until you get out in the industry. I would also say that soft skills are some of the most important things that you have that you can learn and practice. And the engineer that can explain a really complex problem to a number of leaders who are significantly less informed than you are is a huge asset. So learning how to communicate those complex problems, I think, is really important. So if you're still in university, always be the one to volunteer to present. If you get out in industry and they're looking for somebody in the group to present, always volunteer. Take advantage of that, practice, 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 because it is a really important skill in the work that we do. And then I guess finally, I'd offer for everyone to just never stop learning. I'm working on year 37, and I'm driving my team crazy with all the questions that I still ask. But rocket engineering is really bloody cool, and I got a chance to learn about it now, so I'm not going to pass it up. So I'm still going to be out there learning all the way until I retire, and I would say that everybody should be thinking about that. That's what keeps the energy going in the industry that we have.
Thank you. I'll just add a few. I think those of you who are already here, you're ahead of where I was when I was in school. You're in this amazing environment where you get to learn and network with so many people. Networking is your superpower, will be your superpower that will enable you to get to the next place. Because it's the people around you that are supporting you and you're learning from that will ultimately help you get to that next job. And so that, if I can just give a piece of advice that you would remember, is network. And it would surprise me, I would hear some leaders talk about, oh, my friend so-and-so, my friend so-and-so from this airline. I'm like, really, your friends? What? That just sounded silly to me. And it's true, after a lot of time in this industry, your network they become your friends, and it's a small world. I've already seen people here at the conference that I met years ago in London or Brussels. So, it's a small world, and as you continue moving up in it, that network is going to become even more crucial. I asked the follow-on question, what can the earlier generations expect from us, or how do you deal with us? Might be a better question. Have patience. I have teenage daughters right now, and I am technically, well, I wouldn't say savvy, but I can use the internet and ChatGPT and all that fun stuff. But the way that we learned might be just a little bit slower of how we analyze the data, because we didn't have everything available to us all at once. So it takes us a little bit longer to just process some information that you're giving us, and we're going to have a lot of questions on it. And I would say, at least my generation, we don't really always believe in what the data is telling us. So that's something we're going to have to learn as AI continues moving forward. So just have patience with us and recognize that we are all here to learn together, and we're going to learn from you just as much as you're going to learn from us. So I just wanted to add that. We've got some more time for a few more questions, so let me quickly browse through. Actually, while I browse through, Todd, I'm curious. When you started out at Hughes, were you like, hey, I want to be a CTO someday? How did you get into this seat?
Yeah, not that way. I just, kind of like Don, I just enjoy learning. I always want to learn new things. I'd be bored doing the same thing all the time. So that's one aspect. And the other one, probably like many people, I like to have the ability to control my destiny a bit. Mm-hmm. So, early on I got into leadership, but technical leadership, and because of my interest, I've always tried to say technical, not as something I have to remember to do, but just that's what I enjoy doing. And mm-hmm. So I'd say it's those interests that then led to opportunities. I think, that maxim that, focus on doing well and mm-hmm. your career will guide itself. It's not 100% true, but there's a large aspect of that.
Yeah. All right, thanks. Don, what about you?
Yeah, well, I'd say careers are never linear, so don't ever get focused on a direct path to something, or you'll probably disappoint yourself. For me, it was always having fun. Of the 36 plus years, I think I had one job for 8 months that I absolutely hated and was miserable coming to work. So seeking out having fun every day is really, really important. We're fortunate because we get to work on really cool things and play with really cool toys, so it's easy to have fun every day you're coming into work. But I think that's just the number one priority. If I had to design a valve for my entire career, I probably would have died. But getting to work on airplane level integration and airplane things, working on engines one day and carpets the next or something, that's what was really exciting to me. So finding that place where you fit in and what actually excites you and makes you want to come into work every day.
Yeah, thank you. I'll share that for me. It's about the vision, the shared mission. We obviously all started out as engineers, and we ended up going into leadership roles. And I'll tell you, when they first asked me to apply for a management role, I said, no, thank you. And so I think it's interesting when you start planning your career. It is linear. You're thinking, I'm going to go do this one thing, and then there's going to be a curveball thrown your way. And then whether or not you choose to catch that curveball is up to you. I'm glad I've caught some of those curveballs. I've had 2 jobs that I've hated. But what I will tell you is, hindsight's always 20/20, and I've learned the most from those 2 jobs that I hated. I know I don't want to ever do them again, but it gave me insight and appreciation for those that do that type of work. Okay, I want to dive into something talking about cool things. This question came in. What is your opinion on advanced technology tube and wing aircraft, high aspect ratio, relaxed stability versus the adoption of novel configurations to achieve fuel burn reductions? And I mean, I think of like sugar, truss-based wing, et cetera. So,
That sounds like a Todd question.
yeah.
You don't want to learn about that one?
I'm going to sit and listen.
Well, I think it's incumbent upon us to explore that full range and make sure we understand what the capabilities are. So we have been doing just that. So we have investments and collaborations with, for example, NASA on various configurations, including the transonic truss-braced wing configuration. We've done work on blended wing body. We feel it's really important that we understand these potential approaches, these potential technologies, and what their performance is. And I think some of the challenges, it goes back to a little bit of what Don was saying, is you could look at some of these ideas in isolation and they can look promising, but to know whether they're really going to have a net benefit, it's really critical to look at the integrated system and how that particular technology will manifest in a total product. Because oftentimes, in isolation, you can see a benefit, but when you add the things around it to make up a full, in this case, aircraft, it can outweigh some of the advantages. So we explore the range of technologies to make sure we understand their fundamental capabilities, but also, very importantly, look at how they manifest in that integrated design.
Thank you.
I'd just add to that because I think it plays off something you said earlier around every one of these will come with a new hazard assessment and a new failure mode that you've never thought about. And so Todd mentioned getting in and doing the safety analysis early, and that is something that we're doing on these new technologies that come out of Todd's area.
Yeah, great point.
Thanks. We've focused a lot on like, the commercial airplane side, which is what I'm most familiar with. There's a question about space. What's the next big step in the space sector? And it just moved. Sorry, I lost my question. Somebody must have advanced it. So, talking about the space sector, what is Boeing doing that's new technology, advancing our space exploration footprint?
Yeah, there's a number of different dimensions to that. So, right here, and you mentioned at the beginning, we have a Space Launch System, which is going to be involved in the launch, and hopefully in April. Let's take astronauts around the moon, return for the first time. But I think the whole emphasis on getting to the moon and establishing a permanent presence, Boeing and certainly a number of other companies and the president has outlined an objective to make that happen. I think that's really exciting. The ability to sustain humans on another body, I think will provide tremendous learning, tremendous technology advantages. And there's certainly things that go beyond that to Mars and as well as planetary probes. But I think also if you look at the innovation that's taking place in low Earth orbit and the commercialization of space and quite a number of activities, whether it's communications or manufacturing in space, I think there's just a lot of opportunities, and you can see that shift, and it takes a long time, but that shift from, can it be done to, how do we exploit it is happening right now, right in front of us, which is a pretty exciting time. And so we have involvement in various aspects in this different orbital regimes.
What about our defense side? Can you share anything new that's going on?
Well, I think technology continues to advance, and electronics certainly continues to advance. And so, what you can put in a certain volume is rapidly advanced, and it's really important in terms of increasing the capabilities of the sensors that we have in space and how they can contribute to the overall defense of various organizations. So there's a lot going on there.
Awesome. All right, I've got maybe more of it's a work personal question for both of you. What was your biggest challenge, and what has been something that you're most proud of out of your career?
That's a good question. You're welcome to go first.
Well, yeah.
They weren't prepared for this. I just threw it out at them.
Question comes up a lot. You know, you're out with university students. They do tons of recruiting, and these similar questions come up. And you know, the challenges exist every day, and it feels to me like they're all big. I mean, literally. I mean, I'm not making that up. And you know, we walk in one day, and you know, something new has happened, or some accident has happened, or something. And so, it's been a career full of challenges that have all been intriguing and thought-provoking, and things that I really enjoyed participating and helping to solve. And that's where you get the satisfaction, is where you get an opportunity to solve it. So I don't really have one particular one of those challenges or one of those things that I was proud of. You get to the end and you certify a whole new airplane. Of course, your pride goes way up. You know, it's really great to be a part of something like that. But then you come back in the next day and the next challenge is right there in front of you. So it feels like it's an endless loop of all of those challenges and pride and challenges and pride.
Yeah, I'd say that there's, like Don, I could think through many technical challenges, but I think, as you said before, I look at challenges as opportunities. I think the realization that there's only so much one person totally by themselves can do is important. And so figuring out how to harness the smarts of the team and the extended team is extremely important, and understanding relationships. And just one anecdote, my dad was a university professor. So early, before I even went to college, he arranged for me to talk to the dean of engineering at this university. And I thought, this is going to be really fantastic. He's going to tell me about all these cool things, just like your question, that he worked on. So I go in and have the conversation with him. And I walked out completely disappointed, because all he talked about were all these people he worked with and this and that. And it's just, I wasn't smart enough to understand what he was telling me. But you know, over time, I realized that you know, the ability to harness the intelligence of a team is the magic, because you never know where the best idea is going to come from. We all have differing experiences, and it's really important not to have that bias that I have the best answer, or the best answer will be from so-and-so, but really how you leverage the collective wisdom. And the people that can do that are the ones that are extremely successful.
Thanks. Don, what should we be excited about with the 777X?
It's a really great airplane, unbelievable aerodynamics. We're taking it 787 aerodynamics and flight controls to the next place. The interior passenger experience is elevated. Taking advantage of everything we took from the 87 and repeating it, plus adding on it. And for the airlines, it's bloody fuel efficient. It's a moneymaker. That's what everybody should be excited about.
It's amazing. How many parts does a 787 take to put together?
I don't remember.
I think you guys can Google it. I think it's about 1 million. But I did just do the Boeing tour at the Future of Flight, and what I learned about our new 777X airplane is that there are 11,000 suppliers and 3 million parts. So that airplane, when I see it fly, I'm going to be applauding every single time. It's amazing. It's beautiful. They're huge. I'm really excited about it.
One thing to remember, which was often forgotten, is many, many lines of software.
Oh yes, billions, I believe, is what they shared. So it's very complex and amazing aircraft. Okay, do you guys have any questions for me? I've asked a lot of questions. I don't know, figure. Throw it out there. They're like, no.
Well, what's your biggest takeaway from Eco Demonstrator? That's a good learning experience.
Oh, biggest takeaway. Well, yeah. For those of you who are not aware of what the Eco Demonstrator program is, it's a program at Boeing that is housed out of product development, and it takes early technologies, like early TRL technologies, and tests off the certification path, so that we can learn and invest in the things that are going to provide value to the airlines, or not invest in any further, that are going to aid in safety and sustainability goals. So it's been around for about 15 years now, and my takeaway is, well, one of the big takeaways is that we can't do it alone. All of the technologies that are out there, there's a lot of opportunity. However, there's not going to be just one technology that's actually going to really move the needle in terms of sustainability. And sustainability is good for business, right? The airlines have a very small profit margin, and if we can reduce their fuel, they're going to make more money. So, there's also a business component to it. I'll say one of the surprising things is that when I took the position, I had no idea I was going to be doing so much public speaking. But I'll just share. It's an amazing program, and the multi-regional trajectory-based operations was an incredible display of how the entire global industry can come together, work together, and we actually showed the concept is feasible now, not in the future, but now, and that concept is what you're talking about, being able to save 10% of operational efficiency costs. So that's one of my big takeaways. The program's great. Go Google it.
Well, one thing I might comment on, so you can correct my numbers, but I think it's about 250 projects that we've tried. And I think the amazing statistic is about a third of those technologies show up on our real products, which is an amazing conversion rate. But it just goes back to showing the value of not just the technology, but integrating it in a real system, demonstrating it on Eco-Demonstrator, and being able to rapidly flow in. And I think one of the things that we'll see in aviation is much faster upgrade cycles, especially as things become more software enabled.
Absolutely. Actually, thank you for pointing out the technology, because in the expo tomorrow, we're going to have the natural laminar flow winglet that we tested in 2012 on a 737-800 that enabled us to make the design for the split winglet that you see now on all of our 737 MAX. And that winglet enables each aircraft to be about 2% more efficient. So you're going to be able to go and actually, you probably can touch the big test apparatus, and we'll have some experts there to speak about it.
Cool.
All right, well, is there any last thoughts from our team?
No. Thanks for inviting us. Thanks for having us.
Yep.
All right.
Thank you, and just emphasize the point, never stop learning. That's the key.
All right. Thank you, Don. Thank you, Todd. Really appreciate your time.